Okay, so we have established that as x approaches infinity, the function is approaching 2 from below. So as x approaches infinity, the function is approaching 2 from below, which means it's going to be down here below. And then as x approaches negative infinity, it approaches 2 from the above, because these numbers, right, we plot negative 10, negative 100, negative 10,000, the numbers are getting closer and closer and closer to 2, but from above, it's approaching that asymptote. Okay, so we know the behavior that it's approaching the asymptote, so it's going to be somewhere here, and then it's going to be somewhere here. Okay, so from below and from above. So what we're going to do now is we're going to go back to the calculator, graph it on the calculator, and see that this is in fact a horizontal asymptote. Okay, so I'm going to go back to the calculator. Okay, so now I am back in with my calculator, and I put the function in. And what I'm going to do is I'm going to go to zoom, the standard viewing window. Okay, so remember you can just do zoom and then option 6 for the standard viewing window, and we can graph it. And when we graph it, we do see that it is leveling off over on the right hand side, but we can make our x values much bigger and much smaller. So we can go, our x is from minus 1000 to 1000, for example. So we can see as x gets big and small, what happened. I'm going to keep the same y values because that was sufficient. We do see that the function is leveling off here. You can't really see what's going on here, but you can see, right, it is going like this. You just can't see the behavior around the y-axis, but it does look like it's leveling off there at y equals 2. And if we have a more reasonable value, like minus 100 to 100, we will be able to see a more moderate view so that we can see the values around it going up. And it is approaching y equals 2. Okay, so back to the PowerPoint. So we have that last bit to fill out. As x approaches infinity, f of x is approximately equal to 2. Okay, as x goes to infinity, the function is approximately equal to 2. Okay, what we can do is we take our f of x, it equals 2x minus 3 over x plus 5. If I plugged in x equals infinity, right, so if I plugged in instead of this, plugged in, you know, something, you can't actually plug in infinity, but we can plug in something close to infinity, right, so about infinity, kind of use it with parentheses, approximately infinity. This 3 and this 5 really doesn't do anything, right? Because if you have infinity minus 3, well, you're just infinity. So we have 2 times some huge number over some huge number. Well, it's the same huge number over the same huge number. This is approximately equal to 2. So the 3 and the 5 really don't really pay any attention. It doesn't do much because it's approximately equal to 2. Okay, so that is horizontal asymptote and the behavior around horizontal asymptotes. So what you do need is the last bit, which I can't get on the slide, so let me pull that up. Line y equals b is a horizontal asymptote of the graph f of x if f of x approaches that number b as x approaches infinity or x approaches negative infinity. So in our example, as x approaches infinity, our function approached 2, and 2 as x approaches infinity and negative infinity approaches 2. So our b value was 2 in this example. Okay, so that is what a horizontal asymptote. And we're going to now talk about the rules for horizontal asymptotes. So the rules of horizontal asymptotes. So you have your rational function where g and h have no common factor. So we had a polynomial, we factor both of them, and we cross off any like terms. Okay, so it's reduced as much as possible. The degree of the numerator was n, the degree of the denominator was m, the leading coefficient of the numerator is a sub n, the leading coefficient of the denominator is b sub m. So it has a vertical asymptote wherever the denominator equals 0. So you have your vertical asymptote. You just set your denominator equal to 0, and those are your vertical asymptotes. Horizontal asymptotes. F of x has at most one horizontal asymptote, and we're going to compare the degrees. We're going to look at the degree of the top and the bottom. The degree of the top is less than the degree of the bottom, then y equals 0 is a horizontal asymptote. If the degrees are the same, then you take the ratio of the leading coefficient, a sub n over b sub m. You just take the ratio of the leading coefficients, and that is your horizontal asymptote. If the degree of the top is bigger than the degree of the bottom, then there are no horizontal asymptotes. And in section 2.7, we'll see more of those, because in fact they have slant asymptotes. You can even have a parabola-shaped asymptote or a cubic-shaped asymptotes. But essentially, if the degree of the top is bigger than the degree of the bottom, then there are no asymptotes. Horizontal. Okay, so we are going to do this example here, and we are going to find all of the asymptotes. Okay, so for f of x, to find the asymptotes, so for the vertical asymptotes, you set the denominator equal to 0. So you take that, set it equal to 0, and you just solve. Okay, so we have x equals 3 is the vertical asymptote, is the equation x equals 3. Horizontal asymptotes. So to find the horizontal asymptotes, you look at the table. So you look at the degree of the top is 1, the degree of the bottom is 1. If the degrees are the same, we're for the horizontal asymptotes. Our n equals our m, right? Our n is 1, our m is 1. The degrees are the same, so it's y equals the leading coefficients a sub n over b sub n is the b sub m is the leading coefficient. So the horizontal asymptote, you look at the ratio of the leading coefficients, minus 3 over 6, which is minus 1/2. So we have a horizontal asymptote at y equals negative 1/2. So those are all the asymptotes. So for g of x, we can look at the vertical asymptotes. You set your denominator equal to 0. X squared is negative 4. Which tells you x equals plus or minus 2i. We don't have imaginary asymptotes. Okay, so that tells me there are no vertical asymptotes. Okay, so now we're going to find the horizontal asymptote. So you look at the degree at the top, our n equals 1, the degree at the bottom, m equals 2. So since our m is bigger than our n, or in other words, our numerator is less than the denominators, y equals 0 is the horizontal asymptote. Okay, so if the degree of the top is less than the degree of the bottom, the horizontal asymptote is y equals 0. Okay, so that is all we have about horizontal and vertical asymptotes. Tomorrow in class we will have a warm-up about holes and what they are, and then we will put everything together into graphs with an investigation. So I hope you have a great night. I will see you in class.